Hello, this is a video brought to you by Pushcart Ed, and today we will be exploring the concept of the pigeonhole principle. The pigeonhole principle is a very important theorem in math, especially in the field of combinatorics. This video will only cover the basics of the concept, so if you want to see more of this concept and other advanced principles associated with this, leave a comment below. So the basic mechanics of the pigeonhole principle is very simple. Let's assume that there are 4 pigeonholes and there are 5 pigeons. Each pigeon will go into a pigeonhole, so this first pigeon will go into the first pigeonhole, the second pigeon will go to the second pigeonhole, and the third pigeon will go to the third pigeonhole, and so on. But there is 1 pigeon left, therefore if there are 5 pigeons and 4 pigeonholes, there will be at least 1 pigeonhole that has 2 pigeons. For instance, this pigeonhole will have 2 pigeons inside it. So that's the basic concept of the pigeonhole principle. If there are more pigeons than pigeonholes, then at least 1 pigeonhole would have more than 2 pigeons. So let's see the case if more pigeons fly over to the pigeonholes. In this scenario, there are 9 pigeons and 4 pigeonholes. In this case, 2 pigeons can go to this pigeonhole, 2 pigeons can go to this pigeonhole, and so on. When 2 pigeonholes are placed at each of the pigeonholes, 1 pigeon is left. This pigeon can go to any pigeonhole that the pigeon wants, but makes it that at least 1 pigeonhole has to have 3 pigeons. So if we generalize this and put it into a form of an equation, then the equation of the pigeonhole theorem is when there are m pigeons and n pigeonholes, there are at least m minus 1 over n plus 1 pigeons in each pigeonhole. So if we apply this equation in the previous scenarios, in this example, there are 5 pigeons and 4 pigeonholes. So if we put it into the equation, there are at least this amount of pigeons in a pigeonhole, and this is 1 plus 1, which is 2. So there has to be a pigeonhole with 2 pigeons. In this case also, there are 9 pigeons and 4 pigeonholes. So if we put it into the equation becomes 3. So there are at least a pigeonhole that contains 3 pigeons or more inside it. So this principle is very useful in solving combinatorics problems. And these are some problems that are related to the pigeonhole principle. So let's solve these 2 problems. So the first problem is pick 5 integers from 1 to 8 inclusive and show that 2 of their sums equals to 9. Let's write all the integers from 1 to 8. So if we group these integers so that the 2 integers inside a group can sum to 9, there are 4 groups, and the 4 groups are 1 and 8, 2 and 7, 3 and 6, and 4 and 5. So there are 4 groups and 8 numbers. If we pick 5 integers from these 4 groups, that means that if we put it into the pigeonhole theorem, the equation becomes 2. So there is at least 1 from these 4 groups that have both of their integers picked. So let's say that this group is the 4 and 5 group. If both of 4 and 5 are picked from the 5 integers that are picked, then 4 plus 5 equals 9. So we can prove that there are at least 2 integers that sum to 9. The other groups also, 3 and 6, 2 and 7, 1 and 8 also sum to 9. So using the pigeonhole theorem, we proved this problem. Moving on to the next problem, show that among n plus 1 chosen integers, there must exist 2 whose difference is divisible by n. So let's group all of the integer numbers based on their remainder when they're divided by n. Then there will be n groups because there will be groups that their remainder is 1, remainder is 2, remainder is 3, and remainder is n minus 1, and one that is divisible by n, so their remainder is 0. So there are n groups. So if we choose n plus 1 integers from these n groups, then if we use the pigeonhole principle, there are at least 2 integers that are picked from these n groups. So if we say that these 2 integers are x and y, then these 2 integers have the same remainder when they are divided by n. And therefore, x can be simplified into an plus p and y can be simplified into bn plus p. So if we take their differences, y minus x equals b minus a times n, and therefore this is divisible by n, and therefore there must exist two integers whose difference is divisible by n. This is how to apply Pigeonhole principles in these combinatoric problems. So this is the end of what I've prepared for you today, and if you want to see more of the Pigeonhole principle or any other principles in math, you can comment below. Thank you for listening to my explanation on the Pigeonhole principle.